Good morning students, welcome to organic reaction mechanism class. In this class, I would like to discuss about Wohl-Ziegler bromination. Wohl-Ziegler bromination. This is also known as allylic hallucination. This is also known as allylic hallucination with NBS, N-bromosuccinamide, because by using Wohl-Ziegler bromination, we can hallucinate at allyl position in alkene. Okay, so Wohl-Ziegler bromination, and it is also known as allyl hallucination. Okay, so Wohl-Ziegler bromination. What is Wohl-Ziegler bromination? Alkenes on treatment with N-bromosuccinamide and hydrogen bromide in carbon tetrachloride solvent forms allyl bromoalkene. Okay, this is known as Wohl-Ziegler bromination. What is Wohl-Ziegler bromination? Alkenes, when treated with NBS, N-bromosuccinamide and hydrogen bromide in carbon tetrachloride solvent, it forms allyl bromoalkene. So this is a general alkene formula with allyl hydrogen. This alkene have a allyl carbon and this have one hydrogen atom. This alkene on treatment with N-bromosuccinamide, which comes from succinamide. Okay, so and hydrogen bromide in solvent carbon tetrachloride, it forms allyl haloalkene. So what is the main importance of this reaction is when we treat alkene with halogen, okay, molecular halogen, it undergo addition reaction. It breaks the halogen molecule, breaks the double bond and adds to this carbon atoms. Both sides of the double bond halogen is added. So when we treat alkene with halogen, it undergo addition reaction. But when we treat the same alkene with allyl hydrogen with N-bromosuccinamide, it undergoes substitution reaction instead of addition reaction. It undergoes substitution reaction instead of addition reaction. This is the more specialty of Wohl-Ziegler bromination reaction. Okay, for example, we take butene. So if we take butene, when it is treated with NBS, N-bromosuccinamide and hydrogen bromide, it forms two products, that is 3-bromo, 1-butene. 3-bromo, this is the first carbon, second carbon, and this is the third carbon and fourth carbon. So 3-bromo, 1-butene and 1-bromo, 2-butene. 1-bromo, 2-butene. So here two products are formed because the unsymmetrical alkene. So when we take unsymmetrical alkene, there is a possibility to form two different products because of the allyl rearrangement. Okay, if we take symmetrical alkene, then there is a possibility to form only single product. Here we take unsymmetrical alkene. So here two products are formed, 1-bromo, 2-butene and 3-bromo, 1-butene. So in mechanism, what will happen? In the first step, the N-bromosuccinamide reacts with hydrogen bromide. So here N is a heteroatom with lone pair of electrons. It donates the pair of lone pair of electrons to hydrogen and forms a fourth bond with this hydrogen. As a result, hydrogen comes as H plus. Okay, hydrogen comes as H plus to nitrogen atom, and therefore bromine remains as Br minus. Okay, so hydrogen bromide dissociate as H plus and Br minus. Br minus is remains here. Okay, so as a result, donating pair of electrons to the hydrogen, the nitrogen gets positive charge. Okay, to neutralize this positive charge, what will happen? The nitrogen abstracts the electrons bond pair between nitrogen and bromine. So to neutralize this positive charge on nitrogen atom, the nitrogen abstracts the bond pair between nitrogen and bromine. As a result, nitrogen gets neutral charge. Okay, but the bromine atom comes out in form of Br plus. So Br comes out as Br plus, that means electron deficient center. This is electron deficient bromine, and already we have Br minus, that means electron rich bromine. So these two ionic intermediates combine to form molecular bromine. Okay, so the Br minus and here the Br plus comes out from this intermediate, forms molecular bromine. Hence, once molecular bromine is formed, it undergo homolytic cleavage. In presence of light to form two bromine free radicals. One of the bromine free radical reacts with alkene. Reacts with alkene in the way abstraction of hydrogen. So this bromine free radical abstracts the hydrogen free radical. That means this bromine free radical cleaves this CH bond in homolytic way. Okay, in a homolytic way it cleaves this CH bond. So as a result, here hydrogen bromide is formed. That means again hydrogen bromide is formed. Okay, and the alkene is converted into free radical. Especially this is an allyl free radical. This free radical is conjugated with this double bond. So this free radical is conjugated to this double bond. Hence this double bond cleaved homolytically to stabilize this free radical. Okay, so this bond cleaves homolytically, hence the double bond migrates to internally and forms terminal free radical. Okay, so the free radical at third position is rearranged to free radical at first position by resonance structures. So all we know that wherever possible resonance structures, they are more stable. Okay, so the formed free radical from alkene is stabilized by resonance structures. Then after, this carbon free radical cleaves homolytically another bromine molecule. Free radical to abstracts bromine radical. Okay, so if this internal free radical, that means 3 free radical. Okay, so abstracts bromine free radical, this forms 3 bromo 1 butene. If this terminal free radical abstracts bromine radical from bromine molecule, it forms 1 bromo 2 alkane. Okay, so here two possibilities are there for abstraction of bromine free radical due to resonance. So this is the mechanism. So what is happened in the mechanism? In the first step, the N-bromosuccinimide reacts with hydrogen bromide to produce molecular bromine, and this molecular bromine undergo homolytic cleavage in presence of light to produce bromine free radicals. Okay, this is the second step. And in the third step, the bromine free radical formed in this step abstracts hydrogen at allyl carbon to produce allyl free radical. This allyl free radical is stabilized by resonance structures. And finally, this allyl free radical abstracts bromine free radical from another bromine molecule to produce allyl bromoalkene. So here the importance of N-bromosuccinamide is it produces molecular bromine. It produces molecular bromine instantly. Okay. So what will happen if we take directly molecular bromine? What will happen if we take molecular bromine directly is the bromine dissociates the double bond present in the alkene and undergo addition reaction instead of substitution reaction. So here we take N-bromosuccinamide to produce molecular bromine instantly in low concentration. Then only this reaction takes place. Next, note or characteristics of this reaction. Okay, what is the characteristics of this reaction is the first one is if we take unsymmetrical alkene, then we have two allyl positions, and the two allyl positions are different. If the two allyl positions are different, that means in this example, I take 2 pentene. In this molecule, one side the allyl position is allyl carbon and another side the allyl position is secondary carbon. So at which carbon the halogenation takes place is always the halogenation occur at secondary carbon atom. So in a alkene, there is in an unsymmetrical alkene, there are if there are two different carbon allyl positions, then preferred position is first one is tertiary carbon atom, and if there is no tertiary carbon atom, the preference for secondary carbon atom, and there is no secondary carbon atom, then only primary hydrogen is abstracted. Okay, this is the priority order. So in this example, there are primary and secondary allyl positions. Okay, so here the bromine atom is substituted at secondary carbon. If there is a tertiary carbon atom in allyl position, then substitution takes place must be at tertiary carbon atom, because tertiary free radical is more stable. Okay, and the second characteristic of this reaction is if in the molecule have a double bond and a triple bond, both, and a double bond and triple bond, and have different allyl positions for both the bonds. Okay, so if a molecule have double bond and triple bond and these two bonds have different allyl positions, the double bond have allyl position at this carbon and the triple bond have allyl position at this carbon. Okay, so this molecule have two different allyl positions, then where will be the substitution reaction place? So the Wohl-Ziegler bromination reaction is an highly regioselective. The upcoming bromine atom substituted always adjacent to the triple bond. Okay, it is a highly regioselective reaction. The coming bromine atom is always substituted at adjacent to the triple bond. That means the halogen is substituted on this carbon. Okay, so this is the product. And next characteristic is if the alkene have two different two different allyl positions, and then one of the allyl position is brominated selectively. That means so whether the molecule have tertiary allyl carbon, then it undergo first halogenation. Here one primary carbon and one secondary carbon are present at allyl position. So already I told that preferred position is secondary carbon. So hence on bromination with N-bromosuccinamide we can get 2 bromo 3 butene. So substitution takes place at secondary carbon atom. Okay, if we continues this reaction, okay, that means again this compound is treated with N-bromosuccinamide and hydrogen bromide. What will happen is the other side of the double bond is also substituted by bromine atom. The other side of the other allyl position of the double bond also substituted by bromine atom instead of bromine substituted adjacent carbon. Okay, so the newly upcoming bromine atom is not substituted at the adjacent to this carbon atom. Okay, already existing bromine, okay, adjacent carbon. So it comes always to the other allyl carbon. So these are the characteristic properties of allylic halogenation with N-bromosuccinamide. Okay, so I hope all you are understood. So practice the reaction by writing the reaction and mechanism. Okay, thank you.